That's how they walked on the moon, right?
Yeah, nice big steps.
Someday, humans will travel to the moon and Mars, but we probably won't be able to bring everything that we need with us when we go. So we're going to have to get creative.
We're going to need to live off the land. That means utilizing the natural resources of that location to survive. And NASA's working on that.
Welcome to SwampWorks at NASA's Kennedy Space Center. Here, engineers are dreaming up new technologies that will help astronauts live on the surface of other worlds, like the moon and Mars. Nathan Gelino, a research engineer at NASA, put it more succinctly.
You can think of us like the pioneers during the gold rush.
Nathan is working on tools to help astronauts use the resources they'll find on other worlds. An obvious resource that's crucially important to human settlement is water. Scientists are pretty sure that large deposits of water ice exist on the moon, which could be harvested for future missions.
Water can be used for life support systems, drinking water, watering plants, but water is also rocket fuel. So if you use cryogenic oxygen and cryogenic hydrogen and mix them together, that's what rockets use to fly. So you can think of it as being a lunar gas station as well.
And both the moon and Mars are covered with another key resource, regolith, or interplanetary dirt. It's the rocky, powdery soil found on the moon and Mars, but it doesn't have the abundance of organic materials that our soil has. NASA is interested in using the regolith in a number of different ways, like building tools, furniture, and even habitats.
It's not practical to send concrete to the moon or Mars, and so we want to learn how to make building materials out of the resources that are available there.
So let's say I'm going to the moon, but I want to build a habitat there first. What are the things that I need to set up beforehand to make that happen?
First, we need to figure out exactly where they are. We need to do prospecting. We have very small rovers and flyers that are designed to quickly go and take samples in remote locations and find out whether or not there's the material that you're interested in there.
Yeah, send the robots to do that first.
That's exactly right.
The best way to design a robot for prospecting in lunar dirt is to practice with the stuff here on Earth. And at SwampWorks, engineers have built a mini lunar surface based on what we know about the moon's regolith.
I swear, this job always requires me to get into weird bodysuits. Ta-da! Welcome to the lunar surface. So this is what the lunar surface feels like.
Right, so this is a very, what we call a physical simulant.
Okay.
And so it mimics the physical properties of the lunar simulant really well.
So when they were hopping on the moon, it felt a bit like they were on the beach.
Yep.
So crazy. You just would not think that this is the texture of the moon.
Right.
It feels very pillowy.
Yes.
NASA has designed a prototype robot called Razor, designed to harvest lunar soil so that astronauts can build with it.
And so the whole goal of this robot was to be able to dig when you don't weigh very much and you're in a reduced gravity. So we tackled this in a couple different ways. The first was these bucket drums. And so these are actually the excavation and storage tool for the excavator. These scoops, when it's spinning in this direction, it's digging. And then if you spin it this direction, it's able to dump.
So it's basically like one big rotating shovel.
Right, exactly.
So once you have your lunar soil, then what do you do with it? Well, it's time to turn it into building material. NASA has found a way to combine regolith with polymers like plastics or resins in just the right way to create the raw material for printing. And where do you get polymers? Well, astronaut trash should do the trick.
You can take your trash, combine it with Mars or lunar soil,
Yep.
mush it together, and you've got your printer feedstock.
Yep. So you mush it together in a very specific mixture ratio.
Okay.
And what you get is a polymer composite concrete. And so you can make that polymer composite concrete either using the granular material right off the ground, or you can heat up and draw out that granular material into a glass fiber. And then if you use the glass fiber, it makes the material really strong, like carbon fiber or Kevlar.
And that's what we're using today, right?
And that's what we're going to use today.
Right, this is what we're going to be pouring into the 3D printer. You have a whole bunch of trinkets here.
So those are called regos. Those aren't actually printed. Those are sintered regolith.
Yeah.
But they're regolith Legos.
Love it.
Regos are great, but for more complex structures, NASA wants to use its regolith concrete for full-on 3D printing.
With this material, you can do any kind of civil structure that you might need, whether it's a habitat or a blast wall or a road or maybe a hangar. But you also can print furniture or any other kind of things you need. So we're going to print a podium.
I need a podium when I'm going to run the government on Mars, so I need to bang my gavel on something.
This was a pretty slow process, so we didn't get to stick around to see the whole podium. In theory, though, this technology is a game changer. It could one day enable the big settlements on the Moon and Mars that we all love to dream about. But if NASA wants to build entire colonies this way, it'll have to speed things up.
Luckily, this is the first iteration of this design. In the next rev, we're hoping to go to about 100 pounds per hour, which will significantly decrease the amount of time that it takes to print things.
Oh, so how long would it take for this podium to be built if that were going that fast?
I'd say 15 minutes.
Oh, wow.
Yeah.
Call me when you're up at that rate and we'll come back.
That sounds good.